Okay, hello everybody. This video is to help you with 6.4, that is solving systems of applications. So we are doing the same thing we've been working on for the last month, let's say, but now we're going to add story problems to them. So it makes it real world application. So you're doing the exact same thing. You can either solve by graphing, substitution, or elimination. Unfortunately, with real world type problems, it does include more non-friendly numbers. But the most difficult part is setting up the equations. That's what you have to do. Okay, so what I want you to do is, first of all, we are on 6.4 notes, which is on pages 17 and 18 in your note packet. So I want you to have those out. And then I want you to take a look at numbers 1, 2, and 3 here. I want you to look at each of those systems, and I want you to see which technique you would use to solve those if I had those on the summative or formative assessment, okay? So pause the video, try those 3, and then unpause the video, and we'll talk about it, okay? Okay, so taking a look at these. Number 1, you can do it. There isn't really necessarily a right or a wrong answer. Graphing, I would not do unless it's in slope-intercept form, y equals mx plus b. So for number 1 here, I would probably use elimination. And the reason is, and you can write this down, is because the equations are already in standard form. My x's line up with my y's, the equal signs are underneath each other, and then your constants. For number 2, I would most likely use substitution. The reason being is that I already have one of the equations solved for x or y. In this case, it's y equals blah, 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 blah. So you can plug that blah, 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 blah into the other equation for y. The last one, this is one that I would use graphing. And just like I just got done saying, because it's in the form y equals mx plus b, I don't have to do any of the work to get it there, so I might as well just use that. Another technique or method you might use there is substitution. And again, that is because not only is one of these equations solved for x or y, they both are. So I would just go ahead and take one of those and substitute it into the other. Okay? So we're still doing that same stuff, only first we have to write the system. That's our job. So let's take a look at a level 1 type question. Just to pass the summative, you have to be able to do this. Okay? The sum of 2 numbers is 36. So remember, going back to like the first week of school when we talked about translating, sum is the fancy word for addition. So if we add 2 numbers together, we don't know what the numbers are, but if we add them together, they equal, because remember, is the fancy word for equals, 36. So I'm just going to let my 2 numbers be x and y. So the first equation will be x plus y is or equals 36. That's number 1. Number 2, if I have 2 unknowns, I need 2 equations. Their difference is the fancy word for subtraction. And again, I see another is here, which is equals. So this time, instead of adding x and y, I'm going to go ahead and subtract x and y, and it says that their difference is 6. Okay? So what I want you to do is we're going to go through all of these, and I'm going to help you write the systems, and then you're going to solve them. So pause the video and try solving the system however you want to, graphing, substitution, or elimination, and get the correct answer. Or try to at least. Okay, so hopefully you were able to solve that one. And if you solved it correctly, you should get that the 2 numbers are 21 and 15. That would be your final answer. Okay? Now, for the level 2 and 3, it's just a matter of how many different types of problems you can get. Okay, systems you can write and solve to get a C or a B on the summative. So this one, it says a hairdresser finds that he can give 3 haircuts and 3 hair dyes in 315 minutes. The same hairdresser can also give 2 haircuts and 4 hair dyes in 450 minutes. How long does a hair dye take and a haircut take? We have to figure out both of those. So the 2 things that are changing here are the haircuts. How long does it take? Does it take 10 minutes for a haircut? Does it take 40 minutes for a haircut? On average, what does it take? And then how long the hair dyes are. So I'm going to go ahead, and there are 2 scenarios here. The first one is with the 3 haircuts, 2 hair dyes, and 315 minutes. So if one haircut takes 10 minutes, for example, 2 would take 20, 3 would take 30. I would just take 3 and multiply it times however many times or how long it takes for a haircut. So I'm going to go ahead and take 3 times X, and then I'm going to add that, because it's a total amount of time, to 2 times Y, which is the number of hair dyes. That equation would be 3X plus 2Y equals 315. Now I'm going to do the exact same thing for the other scenario. They can give 2 haircuts and 4 hair dyes in 450 minutes. So this time, instead of 3X plus 2Y, it's going to be 2X, because the haircuts are my variable X, plus 4Y, those are the number of hair dyes, is equal to 450 minutes. Okay, so I want you to go ahead and solve that equation, that system, again by graphing, substitution, or elimination, and then check your answer. And that answer should be, it's going to take 45 minutes for a haircut and 90 minutes for a hair dye. Okay, but again, this is going to be part of your homework. You have to fill in all of that missing math that goes from the system to the answer. So don't think that you're just going to copy that down and get credit when you bring that in on Tuesday. Okay? Example, next one. A theater sold, that should be sold, 900 tickets to a play. Floor seats cost $12 each and balcony seats cost $10 each. The total receipts were $9,780. How many types of each ticket were sold? So what we're going to do here, again, we need 2 things. We need to know how many balcony seats were sold and how many floor seats. So I'm going to go ahead and label those variables. So floor seats I'm going to be represented by X, and balcony seats is going to be Y. So anytime I'm dealing with floor seats, I'm going to use X. Anytime I'm dealing with balcony seats, I'm going to use Y. So here we have a lot of money going on. We have $12 for floor seats, $10 for balcony seats, and the total receipts were $9,780. When it comes to a system and you are dealing with 2 things and you're trying to figure out what they are, how much, things like that, you need to keep the same things together. So in this case, I need to keep the money with the money with the money. So it costs $12 for each floor seat. So I would represent that with $12 times however many floor seats I sell. Plus the same thing for the balcony seats, $10 times however many balcony seats I sell. And that total has to be $9,780. So I kept the money for the floor seats with the money for the balcony seats and the total money. Okay? The other equation can come from that there were 900 tickets sold total. So I could sell 450 floor seats and 450 balcony seats, or I could sell 400 and 500. So total, the 2, when they are added together, has to be equal to 900. Okay, so that's how you get your 2 equations there. So go ahead, again, and try to solve that system, and you should get that the floor seats were 390 of them sold that particular day, and the balcony was 510. Okay, 2 more. Next, Jay has written 24 songs to date. That means right now. As of December, whatever, he's written 24 songs. He writes an average of 6 songs per year. So by next year, that should be 30 songs, then 36, then 42, and so forth. Gina started writing songs this year and expects to write about 12 songs per year. So she hasn't started. She hasn't started writing any songs, but she plans to write 12 per year. So how many years from now will Jenna have written as many songs as Jay? So for this one, turns out we're going to write an equation for Jay and an equation for Gina or Jenna. I don't know which one that is, but we're going to write one for each of them, and then we're going to solve it to see when are the 2 equal to each other. Where will they intersect? So we have years that are changing here and songs. So those are going to be my 2 variables. Since the songs depends on how many years it's been, I'm going to let X represent the number of years and Y be the number of songs. Okay? You don't have to. You can you can reverse those. It doesn't matter. That's why it's important to identify what variable you're letting represent years and songs. So the songs that Jay has is going to be equal to the total 24 that he's written to date plus 6 for every year here on after. So that'll have to get multiplied by X because that's the number of years. Then Gina would be Y, the total songs is equal to, she doesn't start with anything, so then it's just going to be 12 times X, 12 times each year she's writing. So go ahead and figure that out, solve it, but you should get the answer of in 4 years, they both will have 48 songs. So before that, Jay has written more. After 4 years, Gina is the winner of writing more songs, if that's what they're going for. Okay, last but not least, test, multiple choice, and true and false. So a test has 20 questions worth 100 points. The test consists of true and false questions worth 3 points each, and multiple choice questions worth 11 points each. So again here, I'm going to keep the points with the points with the points. So I'm going to first identify that true and false is going to be my X, and multiple choice questions are going to be my Y's, just so I know which is which. If I'm taking a look at points and points and points, I know that true and false questions are each worth 3 points, multiple choice questions are each worth 11 points, and then there are a total of 100 points. All of those numbers are going to go into one equation, all 3 of those. So for my system, I have X is true and false. Each one of those is worth 3 points. So if I had 2, I would take that and multiply it times 3. If there were 4, I would take 4 and multiply it times 3. So if I have X, I would take that and multiply it times 3. Add that together with the same thing for multiple choice questions, only that's 11 points for each of them, and the total has to be 100 points. Okay, that's the first equation. The second equation then is going to come from the first part of the system, or the story problem, sorry. A test has 20 questions. So even though there isn't another number per se in the story problem, you have to read to see if it's giving you more information. And here it is. It's saying 20, okay, 20 questions. So again, I can have 1 true and false, and I can have 19 multiple choice. I can have 10 and 10. I can have 18 and 2. All those combinations work, but the idea is that however many true and false plus however many multiple choice has to be equal to 20 total. Can't be anything more than that, okay? Go ahead and try to solve that one, and you should get the answer of there are 5 multiple choice questions, and there are 15, or no, sorry, just kidding. There are 5 multiple choice questions and 15 true or false. I forgot. Okay, so like I said, your homework is to finish solving these examples. I helped you with the difficult part, okay? Setting up the systems. I understand that's the tough part, but now your job is to use graphing, substitution, or elimination to solve all of these, okay? So bring that to me next class, and I will see you later. Let me know if you have any questions, okay? Bye, guys.